Hi everyone, I hope things are going great for everyone. Today I'd like to talk about procedures, and by procedure I mean something we name and something that has a sequence of steps, so things we need to do in a particular order. Many procedures we've internalized in our life. So we have a procedure of how to get dressed in the morning, and as part of that we know that we need to put on our socks before we put on our shoes, or we need to put on our underwear before we put on our pants. And we know how to make a sandwich and the steps involved in that. Sometimes the procedures we don't know how to do. We have to look them up. So even something like a recipe. So here's a recipe book, or partly it's a recipe book. And it's a sequence. Not only does it say the ingredients, but a sequence of steps. So wrap the tofu block in paper towels. We need to do that before we unwrap the tofu and cut it crosswise. And then getting the wok ready. So a sequence of steps. Sometimes the procedures are very formal. For example, in the early 1930s, when they were developing the B-17 aircraft, the first test flight ended with a crash because the pilot forgot to do an important step. So the B-17 aircraft was the first aircraft to have a checklist. So there was a checklist of pre-flight instructions. Before starting, do this stuff. And it was the pilot and co-pilot going through this long checklist. And it resulted in far fewer crashes. It was a successful aircraft when before that checklist they thought it was too complex. Now the checklists for a plane are computerized. It takes a whole book. And for example, here's my iPad. Here's the door forward cargo. What happens if that light goes on? And there's the what happens to reduce the differential, or what the objective is, and then the series of steps. Are you at or below 8,000 feet? If you're, do those steps. If you're above it, do these other steps. This was important because without the checklists, pilots would do whatever at the moment they see this warning light and they try to address the immediate problem rather than the important one, in this case, of reducing the altitude of the plane. So nowadays they have checklists for everything. There's even simple checklists that make a huge difference. For example, in 2001, this Peter Pronovost at Johns Hopkins University, or Johns Hopkins Hospital, developed what's called the ICU checklist. 4 simple steps for the surgeons to do in the ICU. Wash hands with soap and water. Clean the patient's skin with chlorhexidine, if I pronounce it right, antiseptic. Put sterile drapes over the entire patient. Wear a mask, hat, sterile gown, and gloves. So the nurses would watch the surgeons and make sure they did these steps. Now this seems ridiculous, right? These seem so easy. But in doing that, they dropped the infection rate at the hospital from 11% to 0%. So a pretty phenomenal use of a checklist. During Christmas break, I went to Boca Chica to see the rollout of SpaceX's SN9. And here's a picture of my van and my son's van with the SN9 in the background. And you can imagine for something as complex as a spacecraft, there are tons and tons of procedures. And at the upper level, there's something like this, that we need to take that spacecraft from where it was assembled at the high bay, take it to the launch pad. The next step, perhaps, is the cryogenic proof test, where they fill the fuel containers with liquid nitrogen to make sure they can stand the coldness of once they put the real fuel in. We install the engine, do the engine test, and so on. And you can imagine that all these steps in this one procedure have, as sub-steps, some other procedure, right? There's sub-procedures of each of these. This rollout takes many steps to do, so there's a sub-procedure here, and they in turn have sub-procedures. So it's a whole host of nested procedures that can be named, right? We can have the rollout of the high bay. We need to do that on this date. We set that on our calendar. Let's go back to an easy procedure. Here's how to get to my house if you're in downtown Santa Fe, right? It's just, we've used these before where people tell you how to get to your house. Maybe not as common now with Google Maps because we can just find things, but nevertheless a set of instructions. And once we know how to do that, once you've come to my house a bunch of times, not that I'm telling you to come to my house, but once you learn it, you don't need to look at these instructions because it's named. You know how to get to my house. So that's a set of instructions that are named. Now, to get back to our work with the Arduino or any computer programming languages, procedures are extremely important, and we've already constructed procedures. So here we have a procedure called setup, and we have a set of instructions, do these things, one in exactly that sequence within setup. We might set pen mode, serial begin, things that we would need in setup. Here we have a procedure called loop that in turn we can write a set of instructions. This is how you do the procedure loop. You turn on the LED, you might delay for a bit, you turn it off, and in that particular order. This digital write in turn relates to a different procedure. There's a procedure that knows how to do a digital write. It's in what's called assembly language, a very different type of language than we're using, and this is the code for that. Again, you can see these are nested. So it's extremely important to learn how to write these procedures. So for now, consider this void here, these parentheses, and this open and close brace as kind of the English magical incantation of this is how you do the procedure, and then here's the name of the procedure. So this is how you do the procedure loop, and then here's the instructions inside these braces. This is how you do the procedure setup, and then there's going to be a set of instructions. If we wanted to make different procedures, maybe we wanted to do blink. We'd have the magic, we'll learn more about these later, but there's going to be void here, the name of the procedure we want to write, open and close parentheses, and then these braces are the sequence of instructions we need to do. Digital write, delay, or whatever, an if statement, whatever we want in there. So we can name a procedure blink. So we read this, this is how you do the procedure blink, and have instructions. If we wanted to do another one, let's say long blink, goes slow. Open and close parentheses, and then the set of instructions. So our delays in here would be longer. Now, those are just defining it. That's just saying, here's how you do it. If we want to actually do a blink, I'll show you how to do that. So let's do that in the loop. Right, this is one of the required procedures. If we want to execute this, and in computer language or in computer terms, they say call it. We're going to call this procedure, tell it to execute. We just do the name of the procedure, open and close parentheses, and of course we're going to end with a semicolon. And the next thing we want to do is a long blink. We would put it here, open and close parentheses. So this is how you define the sequence of events, the sequence of steps to take to do blink. This is the sequence of steps. This is how you define how long blink is. What are the sequence of steps? When you actually want to do the procedure, this is how you do that. You don't need the void and the braces. All right, so let's turn to our computers and see how this will work.
All right, so we're here at the Arduino IDE, and as I said before, we have two required procedures. We can also call them functions. Functions are slightly different, but people generally use them interchangeably. So one procedure or function is called setup, and one is called loop. These are required, and the definition of them always starts with void, open close parentheses, followed by the set of instructions enclosed in these braces, right? So we can read this in English, as I mentioned before. This is how you set up, and this is how you loop. So let's go not to the blink and the long blink example, but let's switch to Morse code. Not an extremely popular thing nowadays, but it was an important aspect at one point. And let's just look at dots and dashes. Hopefully everyone's heard of dots and dashes. And let's just read through the first three instructions. The length of a dot is 1 unit. A dash is 3 units. And the space between parts of the same letter is 1 unit. So if it's the space between a dot and a dash will be 1 unit if it's within a letter. We'll see how that works shortly. But with that information, we can implement two procedures, one for dot and one for dash. So let's see how that works. So let's do our normal thing, which is let's set the LED to, it's on mine it's in 13, it can be anything, and then let's initialize that unit to be 200. And now we can do the setup. We know how to do that, and the only thing we need to really do is set the pen mode of that LED to be output. And now we are going to work with the dot. We're going to define how to do a dot. And the magic incantation, we'll learn the details in a later video, is the word void, and then we can name it anything we want, but in this case we're going to name it dot. This is how you do a dot. How do you do a dot? Well, you do a digital write, you blink it, we're blinking lights, high, and then remember the dot was 1 unit long, so that would be delay of a unit. Then we turn it off. Excuse me. I'll get it eventually. And for either a dot or a dash, we end up at the end, we have it 1 unit off. So that's the dot. And the syntax is sort of like, this is how you do the dot. You digital write LED high, so you turn the LED on, you wait a unit, you turn it off, and do a unit. So now, once the computer executes this, it'll remember. It knows how to do the dot. Let's do the dash. So this is how you dash. This time we're delaying 3 units. And the delay at the end is only 1 unit. All right, so we have a dot and a dash. Let's use them. And let's use them by creating an SOS. Let me put that up here, actually. So we're going to spell out SOS. So S is 3 dots. Let's just take a look here. So S, right there, 3 dots, O, 3 dashes, and then S again to be 3 dots. Now we have another rule, is that the space between letters is 3 units. So we have to remember that between an S and an O is 3 units long. All right, so let's do SOS. 3 dots, 3 dashes, 3 dots. All right. So first let's do that S. So that would be dot, 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 right? And then the space between letters is 3 units. At the end of a dot, we have 1 unit delay up here, so we need to do 2 more. Okay, that was the S. This is an O. That's dash, dash, dash. And then we delay. And now we're going to do the S again. Let me just copy that. I'll have to fix that up a bit, I guess. And now, at the end of a word like SOS, that space is 7 units long. So we have 1 at the end of dot, so we really have to put 6 here. Okay, I think that looks good. So let's upload it, and we're going to save it now, and we're going to save it in our Arduino course. And this is from experiment 4, so I'm going to create a new folder. And I'll call this Morse code. Makes sense. Okay, now we start the word S-O-S. All right, so we're pretty successful. But notice that we are repeating S twice here. We have an S down here and an S up there. maybe we should make procedures for each letter. So let's go ahead and do that. So I'm going to make the letters. Why not get fancy here with my comment? All right, so I'm going to say this is how you do the letter S. How do you do the letter S? Well, let me actually just do some copy. I think it's actually there. There's my letter S. It's dot, 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 and then that delay of 2 units, so to make 3 total at the end of the letter. So this is how you do an S. And this is how you do an O. Okay, so now we've defined the letter S. This is how you S. You do 3 dots, and then you delay at the end of the letter. And this is how you do an O. You do 3 dashes. Now let's use them in our loop. So we don't need this complexity of all these dots. Well, let me keep that delay there. We'll probably need it. So let's do our SOS. So it's the letter S, followed by the letter O, followed by the letter S. And S ends with 3 units, and we need 7, so we need 4 here. How I got that? Sorry if I was quick. So the dash ends, let's take a look at the dash. The dash ends with 1 unit. Plus we add 2 more, so that's 3. And remember, at the end of a word is 7 units. So we have to add 4 more here. So delay of unit times 4. So we have SOS. How do we do an S? Well, we do an S by looking here at these instructions. We do a dot. How do we do the dot? Well, there's instructions up here that say how to do the dot. So we've defined all the procedures the computer needs to be able to execute this program. Let me go ahead and upload that. And there's that S. There's the O. And there's the S. And let's say I just wanted it to be a little faster. So let's say real fast, because let's say I'm a fast Morse code reader. I'm certainly not. And there we get that nice fast one. That's the beauty of defining things up in variables rather than writing delay 100 or 300 down here. All right, let's make this a slightly more complex problem and say that instead of just doing SOS, which probably might come in handy someday if we're ever stuck on a desert island with an Arduino and an LED and our laptop to program it, we'll be set to message that airplane, provided they can see an LED from some height. But anyway, so let's say we work for a company, and instead of doing audiobooks, they do books by Morse code. Why? I have no clue. So let's imagine doing that, and let's look at one of my favorite books, which is Walden by Henry David Thoreau. And so you can see that we have a lot of text here, and we're going to do this all with Morse code. Let's say I just love watching Morse code as I try to doze off. And you can see that a lot of letters and words, or let's look at words, words repeat. So I have this so I have this word I here that occurs over and over and over again. The repeats a bunch of times, and so on. And let's just say I want to write, as an example, I lived in the woods rather than I lived alone in the woods. So let's say I'm going to do I lived in the woods. Let's see how we can do that. So here I have, I think, Walden, and you see I've defined a few more letters. I have D, E. I think I have all the ones I need for I lived in the woods. All right, so those were the letters. Now let's get some words in. So one word, let's just say words. One word is I. Let's say I pronoun, just so I can distinguish between that single letter I. And how we do that is that's simple. I just use the thing I. The difference between, or the units between words is 7. And an I ends with, this is where math comes in handy. And it's not really necessary with 3, so I need to do 4 here, a delay of 4. Again, this isn't that important in understanding computer science to do this weird calculations I'm doing. So that was I, and now I want to do lived. Whoop. And lived is the letter L, followed by I, V, E, D, and that delay and the reason I'm doing that is a lot of these words are going to repeat in the text. I is going to repeat, lived is going to repeat, and now I can just use lived, as you'll see. Give me a minute here, I'm almost done. The, as you can imagine, is a T, followed by an H, followed by an E. And now the final word, thank goodness, is woods. I lived in the woods. W, O, O, D, S. So there I have, I lived in the woods. And now let's define a function called Walden, because maybe we want to do other books. We're going to send our Arduino device to people so they can watch Morse code of books on Morse code, I guess. I don't know. All right, Walden was, I forget what I called it, I_pro. I'm going to have to look that one up. Let's just see. Yep. So Walden is I, and then followed by the word lived in the woods. Okay, and this, then in loop, the only thing I'm going to do is play Walden. Now, if this works, well, I hope it does. Let's see what errors come. Oh, it looks actually pretty good. And there we go. We're playing I Lived in the Woods on our Morse code device. And let's see that, now that we have these words defined, we can repeat them. So let me just add another word here. Let's say dog. Whoops. Well, let's make it easy and dough. Because we have those letters. D, O, E. And I see I have a problem here because I should have delayed in woods. I hope you guys caught that. And dough. Okay, so now I have the word the twice, and this is where the beauty of all this comes in. So I can say the doe lived in the woods. Let's try that. All right. All right, and let's look at the benefits of these. Well, one benefit is that it's a cognitive benefit from our standpoint, that we can understand. If we had the entire Walden with just digital write, high, delay, if that's all we saw were a slew of digital writes and delays, it'd be very hard, this one huge blob of thousands of lines of digital writes and delays, it'd be hard to wrap our brains around it. But this makes sense, right? Everything's kind of a little module, and we can understand it, right? We can understand these simple dots and dashes, that code. They consist of, these digital writes. Once we get that abstraction, these letters make sense, that a D is a dash, dot, dot. And so they're kind of understandable hunks rather than one humongous program that we're writing. And finally, we get very toward the end where we have the words for Walden, wherever that is here. And, this makes sense to us. We can kind of understand it. It reduces the amount of code we're writing, because instead of writing for the, we'd have to write a bunch of digital writes and delays. This way, we just kind of, once we get one, we can just repeat the word, this procedure, the, and it knows how to do it. So it ends up being shorter programs. So tremendous benefits from doing procedures. It's a very important advance or concept in computer programming. Almost all computer programming languages have procedures or functions. I hate to use that word function because it means something specific in some languages, but a lot of times you'll hear those words used interchangeably. So I hope this was helpful, and I hope you'll be able to use these procedures in different ways throughout your coding through the rest of the course, this Arduino programming course. I hope you have a good evening or day or morning or whatever time it is. Take care. Bye.